long before humans understood mathematics, before there were kingdoms, before there were empires, before anyone had ever even invented a written language, people still watched the sun. They stood there, just like we do today, and they watched the shadows lengthen across the dirt. They watched the seasons change, feeling the air grow cold and then warm again. They watched the stars wheel across the absolute pitch-black canvas of the night sky. And they did this because every single civilization, from the very dawn of humanity all the way to our hyper-connected modern digital age, has always absolutely depended on one entirely invisible thing: time. Welcome everyone to this documentary explainer. Today, we're going entirely down the rabbit hole. We are going to explore the incredible, sprawling, and honestly mind-blowing story of humanity's endless struggle to understand, capture, and master this completely invisible force. Get comfortable because this is the story of us. Okay, let's really dive into this and set the stage. When we look way back at our ancient ancestors, and I mean civilizations so old they left absolutely no recorded written history behind, we find these massive monumental structures. Think of places like Stonehenge, built painstakingly during the Stone Age. Hauling those massive rocks wasn't just some random art project. Historians and archaeologists generally agree it was effectively an incredibly complex astronomical observatory. It was a machine made of stone, designed specifically to track major seasonal events, like the summer and winter solstices, or the spring and fall equinoxes. Think about the sheer dedication that took. These people had no mechanical devices. There were no gears, no springs, no microchips, no instruction manuals. But they possessed this deep, almost existential awareness of the cycles of the universe. They knew that their survival, knowing when the freezing winter was coming, knowing exactly when the herds of animals would migrate, knowing when the rivers would flood, depended entirely on tracking the sky. Nature itself was humanity's very first clock, and our ancestors were incredibly adept at reading it. But that leads us to a really, really profound question, one that has quite literally haunted the greatest minds in human history for millennia. What exactly is time? And how on earth did human beings learn to measure something that they could never, ever touch? I mean, think about it. You cannot hold time in the palm of your hand. You can't put it in a jar. You can't weigh it on a scale. It has no physical form whatsoever. And yet, it completely and totally dictates the rhythm of all life on this planet. It's the invisible current we are all swimming in. So, as we're going to see, the history of timekeeping isn't just a history of engineering or clever mechanical gadgets. No, it's actually the history of human philosophy. It is the story of our relentless, almost obsessive drive to define and organize the very fabric of the reality we live in. Part 1. The Invisible Force, Defining the Unknown. To really begin this journey, we have to look at how humanity even attempted to define this great unknown. Way back in the 4th century, the great philosopher St. Augustine of Hippo spent a tremendous amount of time agonizing over the nature of time. In his famous philosophical text, The Confessions, he wrote a line that I think perfectly captures how we all feel today. He said, "What then is time? If no one asks me, I know. If I wish to explain it to one that asketh, I know not." It's so true, isn't it? It's this deep, intuitive feeling we all share. We feel time passing. But that understanding completely falls apart the second we try to put it into actual words. And when we look back through history, it is absolutely fascinating to see how fundamentally different human cultures have viewed the architecture of the universe itself. For instance, in ancient Hindu philosophy, as described in the sacred texts of the Vedas, the universe goes through these massive, repeated cycles of creation, destruction, and rebirth. We're talking about mind-bogglingly huge cycles lasting over 4.32 billion years. We see this exact same cyclical view of time mirrored in ancient Mayan and Aztec cultures in the Americas. Their view of the world was deeply, intricately tied to the repeating seasons, the looping, endless movements of the sun, the moon, and the stars. Time was a wheel. But then, you contrast that with the Western philosophical tradition. This was heavily championed centuries later by brilliant scientific minds like Sir Isaac Newton. Newton viewed time not as a repeating wheel, but as a fundamental, rigid structure of the universe, an independent, linear dimension. In this Newtonian view, time is a straight, unbending arrow. It moves relentlessly, unstoppably from the past, straight through the present, and right into the future, and it never, ever loops back on itself. These aren't just abstract ideas. These fundamentally different views of the universe dictated how these civilizations lived, built, and eventually how they attempted to measure their days. Part 2. Shadows, Water, and Flow, Harnessing Nature's Rhythms. Now, regardless of whether a civilization believed time was an endless, repeating circle or a straight, unbending arrow, they all faced the exact same practical problems on the ground. You still desperately needed to know when to plant your crops before the frost hit. You needed to know precisely when to perform vital religious rites to appease the gods. You needed to know when to open the markets and conduct business. So, humanity's first great technological leap wasn't building a machine from scratch. It was actually harnessing nature's own built-in rhythms to cast the invisible force of time into something visible. The timeline of human innovation here is just incredible. By 1500 BC, we know the ancient Egyptians were out in the desert heat using these highly sophisticated shadow clocks. They were shaped kind of like a bent T-square, and they used them to meticulously track the sun's journey across the sky. And here's a crazy fact. The Egyptians divided the daylight hours using a base 12 mathematical system. Why 12? Because they observed 12 lunar cycles or moon phases in a single year. That ancient decision, made thousands of years ago in the sands of Egypt, is the exact reason why your digital watch or your smartphone right now divides the day into 12 hours of AM and 12 hours of PM. We are literally still living on Egyptian time. This knowledge eventually flowed across the Mediterranean to the Greeks, and then it was adopted by the Romans. But the quest for precision didn't stop with shadows. Centuries later, we see massive, monumental leaps in Asia. In 725 AD, the brilliant Chinese mathematician and Buddhist monk Yi Xing created a stunningly complex water wheel clock. And that eventually led to polymaths like Suzong, who in 1088 AD built a staggering 30-foot-tall, water-powered astronomical clock tower in China. It was an absolute marvel of ancient engineering, tracking the hours, the days, and the stars all at once. But as with all great human endeavors, the journey of ancient technology was rarely smooth, and sometimes it was actually kind of hilarious. Here is one of my absolute favorite historical anecdotes. In 264 BC, the Romans, expanding their mighty empire, brought their very first public sundial back to the city of Rome. It was a technological marvel placed proudly in the city center. There was just one tiny catch. They had looted this sundial from the city of Catania in Sicily during a military campaign. Now, because the Earth is a sphere, Sicily sits at a very different geographical latitude than Rome. The angle of the sun hitting the Earth is simply different. The Romans at this point hadn't quite grasped the complex astronomical math required to recalibrate the device. The result? This prized, high-tech monument, proudly displayed for all to see, gave the entirely incorrect time to the citizens of Rome for roughly a century. For 100 years, an entire empire was basically running late or early, until a Roman censor finally noticed the astronomical error and had the angles adjusted. It just goes to show that you can have the most advanced technology in the world, but if you don't understand the fundamental laws of nature behind it, it's completely useless. So, while sundials were brilliant and eventually mathematically perfected, they all suffered from one massive, glaring, unavoidable flaw. They were completely, 100% useless at night. And they were equally useless on a cloudy day or during a massive rainstorm. When the sun disappeared, humanity's ability to measure time vanished with it. We desperately needed a new tool, something that didn't rely on the sky. Enter the clepsydra. You might know it simply as the water clock. The word clepsydra actually comes from ancient Greek, and it translates beautifully to water thief. It worked on a wonderfully simple but profoundly effective concept: measuring time through the steady, continuous, regulated flow of liquid either dripping into a vessel to fill it up or draining out of a vessel to empty it. Inside these vessels were markings, and as the water level rose or fell, it hit the marks, and you knew exactly how much time had passed. For thousands of years, literally right up until the 17th century, the water clock was the single most accurate, most dependable, and most commonly used timekeeping device on the face of the Earth. It brought time indoors, it brought time into the darkness. But of course, whenever humanity tries to tame nature, nature tends to fight back. Water clocks were revolutionary, but they came with their own frustrating earthly limitations. Think about the physics of water. If you lived in a climate where the weather got intensely hot, evaporation became your enemy. The water would literally vanish into the air, altering the flow rate and ruining your clock's accuracy. Even worse, if the weather turned freezing in the dead of winter, the water inside the clock would simply turn to solid ice. The flow would cease, and the clock would just stop dead. Winter literally killed time. And I absolutely love the human ingenuity that shines through here. Ancient engineers weren't going to let a little ice stop them. In 976 AD, a truly brilliant Chinese astronomer and mechanical engineer named Zhang Sixun faced this exact problem. He realized he desperately needed a fluid to drive his complex clock mechanisms, a fluid that would not freeze, no matter how bitter the winter winds blowing across the empire got. His solution? Absolute genius. He replaced the water entirely with liquid mercury. Mercury remains a flowing liquid at room temperature and well below freezing. By substituting water with this heavy, toxic, silvery metal, Zhang Sixhun ensured that the heartbeat of his clock kept flowing seamlessly, accurately, and unstoppably, regardless of what the weather was doing outside. Part 3. Fire and Sand, Measuring the Night and the Seas. While giant complex water clocks and mercury-driven gears were being perfected in royal courts, grand observatories, and city squares, everyday people and other cultures looked to completely different natural elements to measure the passage of the night. And when you look at the historical record, there is this striking, beautiful contrast between how the East and the West approach this problem. In China, dating back as early as the 6th century, they developed highly sophisticated incense clocks. Now, if you've ever lit incense, you know it burns at a very slow, very even, predictable rate. And crucially, it burns without a dangerous open flame. This made it absolutely perfect and entirely safe for indoor use in wooden temples, monasteries, and private homes during the night. The craftsmanship was stunning. They would trail the incense powder in long, intricate maze-like patterns. And here is the best part. They would actually formulate different sections of the incense trail with different aromatic spices and woods. As the fire burned through the night, the scent in the room would change. You could be lying in bed in total darkness and literally smell what time it was based on whether the air smelled like sandalwood or cloves. Meanwhile, over in Europe, the elements were harsher and the needs were different. Here, they developed the hourglass. It lacked the sensory poetry of the incense clock, but it was a rugged, unstoppable workhorse of a tool. Unlike water, dry sand doesn't freeze in the cold, and unlike a delicate trail of incense powder, an hourglass is completely unaffected by harsh winds, rain, or crucially, the violent, chaotic rocking of a wooden ship pitching on the high seas. And we really have to pause and realize that time wasn't just some abstract concept used for high-level astronomy or navigation. As humanity got better at measuring time, it began to dictate and govern society, culture, and daily economics at the most granular levels. For example, in Japan, those incense clocks we just talked about, known locally as senko doke, became deeply integrated right into the daily social economy. In the pleasure quarters and tea houses, the highly trained and revered geishas were actually paid for their entertainment and companionship based directly on the number of incense sticks or incense clocks that had completely burned away to ash during their presence with a client. They were literally monetizing the burn rate of a cent. It was a highly visual, elegant, and indisputable way of billing for time. And what's truly amazing is that this fascinating cultural practice, this literal burning of time as a form of currency, continued in certain places all the way until 1924, well into the modern era. But while burning incense was elegantly tracking time in the quiet, sophisticated social gatherings of the East, falling sand was busy tracking time on the deadly, uncharted, violent oceans of the West. When the legendary Portuguese explorer Fernando Magellan set out on his incredibly dangerous, historic attempt to circumnavigate the globe in 1522, he didn't rely on delicate mechanics. He relied on sand. Magellan painstakingly stocked exactly 18 hourglasses on every single ship in his small fleet. This wasn't an afterthought. This was vital to their survival. It was the extremely crucial, high-pressure job of a young ship's page to stand watch and constantly, tirelessly turn these heavy sand glasses the exact second the sand ran out. This constant flipping was how they kept the ship's official log accurate, tracking their speed and estimating their distance traveled across an empty ocean. To keep the sand from drifting too far from reality, they would synchronize the glasses every single day, wait for the sun to hit its absolute highest peak in the sky at local noon, and turn the glasses over. Without these incredibly simple, rugged, dependable bulbs of falling sand, mapping the global oceans, discovering new continents, and surviving the treacherous waters of the 16th century would have been mathematically impossible. Sand literally charted the modern world. Part 4. The Mechanical Revolution, the Heartbeat of Machines. Up until this point in our story, humanity had largely viewed time as something continuous. It was smooth, the silent, gliding creep of a shadow across a stone dial, the steady, unbroken stream of water pouring from a copper bowl, the quiet, smoldering burn of incense in a temple, the endless, fluid slide of millions of grains of sand through a glass neck. But in the Middle Ages, human ingenuity triggered a seismic shift. We changed time from a flow into a pulse. The absolutely crucial, world-changing invention of this era is a tiny, ingenious mechanical linkage known as the escapement. This little mechanism is, without exaggeration, the mechanical heart that changed the world forever. Imagine you have a heavy iron weight tied to a rope wrapped around a cylinder. If you just let it go, gravity takes over. The weight plummets to the ground, the cylinder spins wildly out of control, and all the energy is lost in 2 seconds. It's useless for keeping time. What the escapement does is step in and say, stop, go, stop, go. It's a clever little toothed wheel and a set of pallets that catches that falling weight, completely stops it for a fraction of a second, and then releases it over and over and over again. It regulates the raw power by dividing it into tiny, rhythmic, measurable impulses. It takes the continuous chaotic flow of energy and chops it into distinct mathematical segments. It is the literal birthplace of the tick-tock. And that sound, that rhythm, would soon echo across the entire planet. And if you want to understand just how profoundly these massive new machines impacted medieval society, you just have to look at the language we still use today. The English word clock, the word we use for watches, digital timers, everything, didn't originally mean a device that tells time. That wasn't its definition at all. The word actually traces its roots back through Middle English to the post-classical Latin word clocca. And clocca simply means bell. That's because in medieval Europe, when these massive iron gear-driven mechanical clocks were first invented, they didn't even have faces. There were no hour hands, no minute hands, no dials to look at. They were giant, ugly, complex machines hidden away high up in the dark, dusty towers of churches and monasteries. Their one and only purpose was mechanical muscle. At the top of the hour, the escapement would trigger a massive gear that would swing a heavy hammer and physically strike a giant bronze bell. The booming sound would ring out from miles over the entire city, washing over the fields, the markets, and the homes. It told the monks when to pray, the merchants when to trade, and the farmers when the day was done. It completely synchronized the lives of thousands of people at once, purely through sound. You cannot overstate what a monumental psychological shift this was for human civilization. For thousands of years, we were tied to nature, but suddenly, time was no longer a silent, continuous flow, tethered strictly to the organic rhythms of the sun, the weather, or the seasons. It had become an oscillating, rigid, mechanical pulse. It was a machine that humanity had built. This transition fundamentally paved the way for modern industrial society as we know it. Before the mechanical clock, you worked until the job was done, or until it got too dark to see. After the mechanical clock, human labor, factory shifts, train schedules, and entire global economies could be fiercely monitored, optimized, and dictated by the rigid, relentless, totally unsympathetic ticking of iron gears. The clock didn't just measure our days anymore. It began to master them. Part 5. Synchronizing the world, the longitude problem. As time marched on and European nations began to build massive wooden armadas to cross the vast, terrifying oceans in search of global empires, they slammed into a deadly scientific roadblock. Knowing the exact time at sea suddenly wasn't just a matter of convenience so you wouldn't be late for a meeting. It was quite literally a matter of life and death for thousands of sailors. Here was the issue: navigation. Figuring out your latitude, how far north or south you are from the equator, is relatively easy. You just measure the angle of the North Star or the sun above the horizon. Easy. But figuring out your longitude, your east to west position, was the greatest scientific puzzle of the age. The only mathematical way to calculate longitude on a featureless ocean is to know your exact local time by looking at the sun and compare it to the exact time back at your home port. The time difference tells you how far across the globe you have sailed. But hourglasses were too inaccurate for long voyages, and pendulum clocks, which had become standard on land, were utterly useless on a violently pitching rolling ship in a storm. The gravity gets messed up and the clock stops. Without longitude, ships were literally sailing blind, often crashing into rocks in the dead of night, killing everyone on board. Enter a brilliant, self-educated English clockmaker named John Harrison. He realized traditional clocks would never work, so he spent decades of his life obsessively working to solve this. And finally, in 1761, he succeeded. He built a radically stable, intricate device called a marine chronometer. It was basically a giant, highly complex pocket watch, immune to the rocking of a ship and changes in temperature. On a grueling, treacherous, multi-month test voyage from England all the way to Jamaica, Harrison's masterpiece, known as H4, was accurate to within an unbelievable 5 seconds. It was a feat of engineering that many of the greatest scientists of the time, including Isaac Newton, thought was practically impossible. The sheer scale of the consequences resulting from Harrison's chronometer is truly staggering to think about today. By finally solving the longitude problem, John Harrison didn't just tinker in his workshop and make a slightly better clock. He quite literally unlocked the oceans for humanity. Because ships could now carry exact time with them across the globe, safe, reliable global navigation became a reality. Captains actually knew where they were. This single technological breakthrough fueled the rapid, explosive expansion of global empires. It allowed map makers to finally chart the true shapes and distances of the continents. It opened up massive, safe shipping lanes and laid the absolute, unshakable bedrock for international trade and the heavily synchronized, industrialized global economy that you and I participate in every single day. A pocket-sized clock conquered the globe. Part 6. The Atomic Age, Measuring the Microscopic. Which brings our journey screaming into the modern era. Just look at the trajectory of humanity. We have gone from standing in the desert looking up at the massive, blazing sun in the sky, to watching the slow, earthly flow of water, to listening to the heavy, mechanical swing of an iron pendulum. Today, our insatiable pursuit of absolute precision has driven us to stop looking at the macro scale of the universe and start looking at the invisible, microscopic vibrations of the quantum realm. 200 million. Take a second to just let that number sink in. 200 million. That is the number of years that a modern super-precise optical atomic clock can operate continuously without losing or gaining a single solitary second of time. We have completely transcended gears and springs. By using lasers to measure the natural, perfectly consistent resonance frequencies of atoms, like cesium or strontium, scientists have created timekeeping devices so unfathomably accurate, so mind-bendingly precise, that they almost defy human comprehension. We are now slicing time into segments so infinitesimally small that a single second feels like an eternity to these machines. You know, theoretical physicists often joke, as it's famously noted in the Internet Encyclopedia of Philosophy, that when you really get down to the math of it all, time is simply what clocks measure. It sounds like a cheeky dodge to a deep philosophical question, but in our modern, hyper-connected world, that statement is the literal, practical truth. Our world doesn't run on the sun anymore. We rely entirely on the staggering and visible precision of these atomic clocks. They are the hidden scaffolding of modern civilization. We use them to perfectly synchronize the network of global positioning system satellites orbiting in deep space, allowing the map on your phone to pinpoint your car on a highway. We use them to route massive packets of data seamlessly across the internet cables running along the ocean floor. We use them to timestamp billions of high-speed financial transactions on the global stock markets every single second, preventing total economic collapse. If the atomic clocks of the world suddenly failed today, our entire modern technological civilization would grind to a chaotic, devastating halt within hours. We are totally, inescapably dependent on this precision. So as we look back over the thousands of years we've covered, it becomes incredibly clear. The history of timekeeping is not simply a dry story of brass gears, dripping water, falling sand, and vibrating atoms. It is the story of humanity itself. Every single civilization we've built, every new continent we discovered, every treacherous journey we survived, every empire that rose and fell, and every massive scientific breakthrough we achieved depended entirely on our ability to understand, capture, and master one invisible force: time. From a crude, dark shadow cast on the Egyptian sands by a simple stick, to the microscopic atomic vibrations currently guiding our spacecraft through the cold void of the solar system, we as a species have never, ever stopped chasing the clock. And it leaves us with one final profound question to consider. As we continue to push further into the cosmos, what will future civilizations use to measure their journey? If you enjoyed this documentary explainer, please take a second right now to like the video, subscribe to the channel, share this with a friend who loves history, and join us here at SketchMind as we continue exploring the incredible, fascinating stories that make us human. Thank you so much for watching, and we will see you next time.